Hi, everyone. We're continuing with section 4.7 on evaluating inverse trig functions. First off, here's a cute meme I found online. Actually, it should say, hey girl, what's your inverse sine? Because the inverse sine of 1 is pi over 2. But let's get back to business. All right. Let's evaluate the inverse sine, or the arc sine, of negative root 2 over 2. And I'll give you 20 seconds to figure this out. I'll give you a few hints first. Again, what are we looking for? We're looking for an angle. We're looking for an angle. The inverse sine or arc sine of negative root 2 over 2 is what angle? First of all, you agree that negative root 2 over 2 is a sine value. In fact, it's a famous sine value. It's a famous special sine value. It's not like negative 10 or something. So we will have an answer. It will not be undefined. So what we want then is an angle such that the sine of box, the answer, is negative root 2 over 2. You're looking for an angle whose sine value is negative root 2 over 2. And it has to be in the range of the inverse sine function. In the range of the inverse sine function, or arc sine. So two conditions here. The sine value has to be negative root 2 over 2, and it's got to be in the range of inverse sine or arc sine. 20 seconds, go. Okay, so let's start to figure this out. Now, we want an angle whose sine value is negative root 2 over 2. But that negative sign makes things a bit more difficult for us. So instead, why don't we do this? The answer is not going to be quadrantal, because negative root 2 over 2 is not the sine value for a quadrantal angle. So let's find the reference angle. Okay, find the reference angle for the answer. Remember, the answer is basically like an angle. So I want to know a nice acute reference angle such that the sine of that angle is positive root 2 over 2. Positive root 2 over 2. So consider the unit circle. All right. I want an acute reference angle whose sine value is positive root 2 over 2. And I hope you remember that that's going to be pi over 4. In fact, that's the inverse sine of positive root 2 over 2. But we want the inverse sine of negative root 2 over 2. And that's going to be a brother for pi over 4. But in which quadrant? Well, in what two quadrants is the sine value going to be negative? In what two quadrants will the sine value be negative? In quadrants 3 and 4. It's like y coordinate. The sine value is negative in quadrants 3 and 4. But now wait, we also need our answer to be in the range of the inverse sine or arc sine function. And what is the range for the inverse sine function? From negative pi over 2 down here, I'll put this in red. From negative pi over 2 down here at the south pole, up through positive pi over 2 up at the north pole. So I want an angle in either quadrants 1 or 4. So which is the only quadrant where the sine value is negative, and it's going to help us with the range for inverse sine? It's got to be quadrant 4. We need a brother for this angle in quadrant 4. So a student might say, oh, I guess the answer is going to be 7 pi over 4, because the sine of that is negative root 2 over 2. That part's right, but is this the answer? The answer is no. That's not the answer. That's 0 credit. Because 7 pi over 4 is not where? It's not in the range of the inverse sine function. Your answer must be in the range of the inverse sine function. And 7 pi over 4 doesn't cut it. So what coterminal twin will cut it, will work? The range for inverse sine goes from negative pi over 2 to pi over 2. The only brother here in quadrant 4 that's going to work is going to be negative pi over 4. And that is going to be the answer. So we know that sine of negative pi over 4 is negative root 2 over 2. And it is in the range of the inverse sine function, or arcsine. It's between negative pi over 2 and pi over 2. So we conclude that this is the answer, the value for this. Sine of negative pi over 4 is that, and it's in the range of the inverse sine or arcsine function. Negative pi over 4 is our answer. Next up, how about the inverse sine of 3, or arcsine of 3? The inverse sine of 3 is what angle? Well, wait a minute. The sine of what equals 3? Is any angle, is any real radian measure going to work in this box? The answer is no. Inverse sine of 3 is undefined, or at least it's not real. Actually, imaginary numbers may work, but we're going to keep it real. This thing is undefined. It's not real as far as we're concerned. Because 3, guess what, is not a sine value to begin with. In a way, that's the very first step. Ask yourself, is 3 even a legitimate sine value? It's not. It's not a sine value. Remember in the loop-to-loop picture that we had way up here, okay? The sine function outputs values between negative 1 and 1. That's the range for sine. And for the inverse sine function, we're only allowed to input sine values, values between negative 1 and positive 1. If you input something on the outs, like 3 or negative 3, then the result is undefined. It's not real. 3 is not a sine value. No go. Likewise, the inverse cosine of 3 or the arc cosine of 3 will also be undefined or not real, because 3 is not a cosine value either. What about inverse tangent of 3, or inverse tangent of 10, or inverse tangent of 100? I'll skip all the way down here, actually. The inverse tangent of 10 is defined. It is real, about 1.47 radians, which, by the way, is going to be pretty close to pi over 2. Why is that? Now remember, if this is a positive, legit trig value that we're looking for, then the answer is going to be either an acute angle or quadrantal. All right, now we want an acute angle in this case that corresponds to a slope of 10. So it's going to be a pretty steep angle. That's why 1.47, the approximate answer, is pretty close to pi over 2. It's pretty close to pi over 2, which is about 1.5 to 1.6. But yeah, The answer to this is an angle in radian measure corresponding to this ray, this terminal side, with a slope of 10. This angle does exist. So inverse sine of 10 is undefined or not real. Inverse cosine of 10 is undefined or not real. But inverse tangent of 10, that is real. It's about pi over 2. It's actually more like about 1.47 radians. It's a pretty steep angle. Now, going back to this example here. Evaluate the inverse cosine or arc cosine of negative 1/2. 20 seconds, go. So let's try to figure this out. All right. So the inverse cosine of negative 1/2 equals what? First of all, I need an angle such that cosine of that angle is negative 1/2. And you agree that there are angles whose cosine values will be negative 1/2. In fact, negative 1/2 is a very famous special cosine value. Let's get to first base here, right? I mean, negative 1/2, that is a legitimate cosine value. This is, in fact, a cosine value. All right. Again, if that were like -3 or +3, we're done. Undefined, we're done. But we are going to have a real answer here. First of all, I need an angle whose cosine value is negative 1/2. A student might say, wait, there are infinitely many angles that do that. Well, yeah, but we need the one angle in the range of inverse cosine. We need this to be in the range of inverse cosine or arc cosine. And there's only one angle that's going to do that, whose cosine value is negative 1/2, and that's in the range for the inverse cosine or arc cosine function. All right. Now, first of all, it might help to find the reference angle. You might tell that the answer will not be a quadrantal angle. Find the reference angle for the answer. In particular, I want to find an angle such that the cosine of this reference angle is positive 1/2, because that's an easier question to answer. In fact, you might have a table or a unit circle picture ready-made for this. The cosine of what famous acute reference angle is positive 1/2? Well, it's going to be sort of to the left. It's going to be the steep angle. It's going to be pi over 3. That's the reference angle for the answer. But that's not the answer. Okay, it's the reference angle for the answer. It's the reference angle. But wait, in red, we want to get the actual answer. So first of all, cosine of what will give us negative 1/2? Well, quadrant is key here. In what two quadrants will cosine be negative? Cosine is like x coordinate on the circle. Cosine will be negative in either quadrant 2 or quadrant 3. The cosine value, or x coordinate on the circle, will be negative. Now it's a question of range, because the answer has to be in the range of our cosine, or inverse cosine. The range for inverse cosine, remember, goes from 0 radians up through pi radians. So which quadrant does the answer have to be in? The answer has to be in quadrant 2. We need a brother for this point over here. The answer has to be a quadrant 2 angle, because quadrant 3 angles are not in the range for arc cosine. So who's the key famous brother we want in quadrant 2 that's in the range between 0 and pi? Only one. 2 pi over 3. That's got to be the answer. We know cosine of 2 pi over 3 is negative 1/2. And again, 2 pi over 3 is in the range of the inverse cosine or cosine function. The range, by the way, is from 0 to pi. So the answer here is going to be 2 pi over 3. And don't put any other angles. If you put any other angles, that might be no credit because then you don't know what a function is. Remember, a function is not allowed to spit out more than one value. So if you put more than one value here, I have the right to give no credit because you don't know what a function is. That's a problem. Way back in chapter 1. Okay, 2 pi over 3. Next up, we're going to talk about the inverse properties, which will be the subject of the next video.